It was impossible. It was beautiful. It was the seafloor's confession. The Earth's magnetic field had reversed again and again, and each reversal had been locked into the cooling stone as molten rock rose, spread, and froze along the ridge. The Atlantic had been recording the planet's magnetic memory for millions of years, and suddenly everything made sense. The trembling compasses, the drifting needles, the strange corridors of distortion, the pulses, the whispers. They were all part of a single immense story, a story written by the shifting heart of the Earth itself, preserved beneath an ocean that had been silently guarding it for ages. Yet even as this revelation reshaped our understanding of geology, one truth remained. The Atlantic was still hiding more. Far more. Even with the revelation of magnetic striping and pole reversals, the Atlantic refused to become predictable. If anything, the deeper scientists probed, the more erratic and complex the signals became. The oceans seemed to offer clarity with one hand and concealment with the other, revealing the grand design of plate movement while hiding the delicate mechanisms beneath. The magnetic patterns were now understood as echoes of the planet's shifting poles, but interspersed among these elegant stripes were disturbances that defied every model. Some anomalies were too sharp, too abrupt to be explained by slow geological change. Others presented magnetic intensities far stronger than the surrounding crust. A few were so oddly shaped, twisting in tight knots, spiraling like frozen storms, that they looked less like natural formations and more like something sculpted. These were the anomalies that unsettled even the most seasoned researchers, the ones that seemed to pulse when instruments drew near. One oceanographer described them as magnetic reefs, invisible structures rising from the seafloor, warping the field like unseen mountains. Another, more poetic in his frustration, called them the scars of Earth's temper. But no matter how many theories were proposed, the truth remained elusive. The Atlantic's magnetic field was not a tidy record. It was a living archive full of disruptions, interruptions, sudden changes, and unexpected intensifications. And those intensifications were the most perplexing of all. In certain deep water regions, particularly around branching fractures of the mid-Atlantic ridge, magnetometers recorded spikes so pronounced they overwhelmed the instruments. Metal objects aboard ships, wrenches, bolts, even parts of the hull vibrated subtly, as if responding to an unseen force. Some crew members reported headaches. Others felt sudden warmth spreading through their limbs. One researcher swore he heard a faint ringing in the air, a thin metallic hum that vanished as quickly as it came. This was not imagination. This was the Earth communicating through magnetism. As technology advanced, sensors were lowered deeper into the water column, suspended by cables that stretched like metallic threads into the darkness. These instruments, designed to operate in crushing pressure, detected fluctuations that grew stronger with depth. It was as if the ocean's magnetic anomalies were concentrated near the seafloor, hidden beneath layers of cold, silent water. The deeper the sensors traveled, the more the field distorted lines that should have been smooth became jagged, while stable regions turned chaotic. And still, the seafloor remained out of reach. Human eyes could not pierce the darkness. Early underwater cameras produced only grainy images. Blurred rock formations, drifting silt, the occasional crimson jelly pulsating like a ghost. But even in these unclear images, there was a sense of something ancient, something immense. The Atlantic was not merely a basin filled with water. It was the boundary between two enormous plates slowly ripping apart, its floor constantly renewing itself through eruptions of molten rock. Every eruption carried minerals rich in iron, and every time that iron cooled, it aligned with the magnetic field of the moment, capturing the Earth's state in stone. Some regions held these magnetic signatures perfectly, like pages of a well-preserved book. Others appeared torn, overwritten, or erased. It was the erased sections that troubled scientists most. Why were there zones where the magnetic field seemed to vanish? Why did some areas show signatures inconsistent with any known pole orientation? And why did certain anomalies form small, circular patches as though something had melted, shifted, or forcibly rearranged the minerals beneath? These questions lingered like fog around every expedition. Researchers debated fiercely. Was it volcanic overprinting? Local magnetization from hydrothermal vents? Uncharted iron deposits? Or something entirely unknown? Amid this uncertainty, something subtle changed in the way explorers viewed the Atlantic. It no longer felt like they were studying the ocean. It felt like the ocean was studying them. Sensors malfunctioned more frequently in high anomaly zones. Batteries drained faster. Communication cables experienced interference patterns that rippled like static across the water. Even sonar, normally unaffected by magnetic fields, behaved unpredictably, producing echoes that stretched into strange shapes. Some sonar returns resembled arches or pillars that vanished upon rescue. Others came back fractured, as if something solid had briefly occupied the beam's path. There was no proof of anything unusual, yet the feeling persisted. The Atlantic was not just reacting, it was responding. By the end of the chapter's timeline, one truth had become undeniable. The magnetic anomalies of the Atlantic were not simply geological curiosities. They were clues, warnings, records, and perhaps even signals. Signals that hinted at forces still moving beneath the crust. Signals that told stories far older than humanity. Signals that whispered of deeper mysteries waiting in the darkness. And though scientists had learned to recognize the patterns, they had only begun to understand their meaning. The Atlantic still held its deepest secrets close. It always had. Even after decades of exploration, the Atlantic's magnetic disturbances refused to settle into simple explanations. With each new expedition, the map of anomalies grew denser, more intricate, more defiant. What had once seemed like isolated irregularities now appeared woven into a vast network threads of magnetism stretching across the seafloor like veins beneath skin. And in this deepening complexity, scientists began to sense something they had not anticipated: a rhythm. Not a literal beat, not a pulse measured in seconds or minutes, but a slow, geological cadence patterns in the anomalies that hinted at cycles older than continents. When researchers layered decades of data together, they noticed subtle shifts, intensifications, soft lulls, as though the magnetic field and the crust it shaped were breathing in ways too slow for a human lifetime to perceive. Some dismissed the idea as coincidence. Others insisted nothing in geology is accidental. But for those who listened closely, the Atlantic seemed alive with motion, not the surface motion of waves, but the deep, internal movement of a planet still forming itself. The magnetic anomalies, they argued, were not random distortions. They were messages written in the language of molten rock, pressure, and time. That realization ushered in a new kind of curiosity. Scientists no longer asked merely what caused the anomalies. They asked why. Why here? Why so many? Why in patterns that defied clean symmetry? And why did some regions seem to grow stronger over the span of a single generation? In the mid-1990s, a landmark deep-sea survey brought those questions to a turning point. Using a new class of highly sensitive magnetometers towed just above the seafloor, researchers captured readings far more detailed than anything previously recorded. For the first time, the anomalies appeared not as jagged spikes on paper charts, but as sprawling, textured landscapes, valleys, cliffs, and spirals carved in invisible force. One formation in particular, located along a fracture zone stretching outward from the mid-Atlantic ridge, left the team stunned. The magnetic field there twisted into a spiral shape nearly 3 kilometers wide, a perfect arc etched into the crust. Its pattern was so precise, so deliberate, that some aboard the ship wondered aloud if nature could even produce such geometry. The official explanation, cooling magma interacting with shifting polarity, was perfectly reasonable. But the spiral symmetry clung to the imagination, whispering of deeper order, deep structure, deep memory. That night, as the ship drifted under a sky salted with stars, one geophysicist wrote quietly in her notebook, "The Atlantic remembers things the rest of the world has forgotten." Her words resonated far beyond the poetic. They captured a newfound truth. The seafloor was not static. It shifted, stretched, twisted itself into forms that could be read like archives. Archives of polarity. Archives of eruption. Archives of the Earth's own internal storms. But even as science advanced, the human experience of these anomalies remained unchanged. Sailors crossing the high anomaly corridors still felt uneasy, their instincts prickling as though entering a place slightly out of joint with the rest of the world. Pilots flying low over the water reported brief compass hesitations, unexplained drifts, small but undeniable. Underwater cables laid across anomaly zones experienced faint but measurable fluctuations in electromagnetic interference, as if brushing against unseen currents. And through it all, one impression grew stronger. The Atlantic was not chaotic. It was deliberate. Its distortions hinted not at disorder, but at a system too vast and ancient to understand fully. For centuries, humanity believed that the mysteries of the ocean came from the surface storms, waves, currents, creatures. But the true mystery lay far below, where rock cooled in the dark and recorded the shifting moods of the planet. By the close of this chapter, one thing had become unmistakably clear. The trembling compasses of the past were not errors. They were invitations. Invitations to descend deeper, to listen more closely, to read the magnetic script etched into the earth. Because beneath the calm surface, beneath the gray Atlantic sky, beneath the ancient ridge that splits continents apart, something was still writing. Something that had been writing for millions of years. And its next chapter waited in the fault lines below. Beneath the Atlantic's restless waves, the earth breathes in slow, imperceptible rhythms. The surface swells and retreats, but the true motion lies kilometers below, where tectonic plates grind against one another with the patience of eons. These are the fault lines, the deep, invisible seams where the planet stretches, compresses, and sometimes rages. They are scars and lifelines at once, carving the seafloor into ridges, trenches, and fractures that guide not only the movement of continents, but the flow of magnetic energy itself. Here, the Atlantic begins to reveal its dual nature, a tranquil expanse above and a churning, violent world beneath. Early oceanographers had long suspected the seafloor was not flat. The discovery of the mid-Atlantic ridge in the mid-20th century confirmed it, and with it came a realization more profound than topography alone. The ridge was a wound that the Earth never healed, a constantly renewing fracture, where molten rock rose, cooled, and locked the history of the planet into the crust. Alongside this ridge stretched countless subsidiary fault lines, narrow yet immense, many hidden beneath layers of sediment and the crushing weight of water. These faults were alive, shifting slowly but continuously, reshaping the very magnetic identity of the ocean above. It is along these faults that the Atlantic's magnetic anomalies are most pronounced. Iron-rich minerals in newly formed rock align with the planet's magnetic field as they solidify, capturing a snapshot of the Earth's polarity in stone. Over millions of years, these formations record the relentless march of tectonics and the subtle oscillations of the magnetic field. When a fault shifts abruptly, or when a volcanic vent erupts, these magnetic patterns distort. Compasses sway. Instruments falter. It is a language of invisible force, written in iron and stone, awaiting translation by those patient enough to observe. The faults themselves are not uniform. Some are wide and gentle, allowing plates to slide past one another with minimal friction. Others are narrow, jagged, and unpredictable, where rock fractures under pressure, releasing energy in sudden bursts that ripple across the ocean floor. Hydrothermal vents often mark these fractures, spitting mineral-rich plumes into the dark water. These vents create localized magnetic anomalies, adding layers of complexity to the field above. When instruments pass overhead, they detect not just a linear disturbance, but a shifting mosaic of intensities, like reading a weather map for a storm you cannot see, only feel. Early submersible expeditions revealed the physical grandeur of these fault lines. Towers of basalt rose from the abyss, cliffs that sliced through darkness like the blades of forgotten giants. Valleys deep enough to swallow a mountain in shadow stretched for kilometers, their walls lined with hardened lava and crystallized iron deposits. In these remote corridors, the magnetic anomalies were strongest, their pulses detectable hundreds of meters above the seafloor. It became clear that the faults were not merely fractures. They were conductors, channels through which the Earth's magnetic memory flowed and sometimes convulsed. Yet the faults are not static. Earthquakes, even minor ones, ripple along these lines, subtly altering magnetic signatures in ways impossible to predict. A single tremor can realign iron-rich deposits, creating local distortions that echo far beyond their immediate vicinity. Over centuries, repeated movements compound, producing a labyrinth of anomalies that can mislead even the most sophisticated instruments. A compass might drift here, hesitate there, as though the ocean itself were testing the observer, reminding them of the vast forces at play beneath their feet. The mid-Atlantic ridge and its network of faults also play a role in shaping ocean currents. Deep water flows navigate these undersea valleys and ridges, carrying heat, minerals, and life across vast distances. The movement of water over magnetized rock subtly affects the ambient magnetic field, creating temporary anomalies detectable by modern sensors. The Atlantic, in this way, becomes a layered system of interacting forces, geological, magnetic, and fluid dynamics converging to form a hidden, intricate pulse. Only by observing all three together can the ocean's underlying architecture begin to make sense. And yet, for all the science, the Atlantic retains a sense of mystery. The deeper the faults plunge, the less humans can reach. The instruments relay numbers, charts, and graphs, but the tactile experience of the seafloor, the texture of rock, the silent weight of pressure over kilometers of water remains inaccessible. The ocean preserves this unknowable scale, reminding us that fault lines are not just breaks in rock. They are thresholds into a world that exists beyond ordinary perception. It is here, amid the fractures and ridges, that explorers sense the Atlantic's true power, the ability to shape magnetic fields, to distort instruments, and to leave an indelible imprint on every journey that crosses its waters. The Atlantic's faults are more than lines on a map. They are the ocean's skeleton, supporting the weight of water above while constantly reshaping themselves below. Each fracture tells a story of pressure, eruption, collision, and slow, inexorable drift. The mid-Atlantic ridge alone stretches for thousands of kilometers, a central spine that divides continents and channels the planet's magnetic heartbeat. Along this ridge, smaller faults branch off like veins, carrying both molten rock and hidden anomalies that reach far beyond their immediate location. These fractures are where science meets the sublime, where data becomes poetry, and measurement begins to feel like translation of the planet's secret language. Modern expeditions using remotely operated vehicles and advanced submersibles have revealed landscapes that defy the imagination. Sheer walls of basalt rise hundreds of meters, textured with ridges and cracks that trace the stress lines of the Earth's interior. Hydrothermal vents pepper these formations, their mineral-rich plumes twisting in the current, depositing iron, manganese, and other magnetically sensitive materials onto the ocean floor. As these minerals accumulate, they subtly warp the local magnetic field. Instruments passing overhead detect shifts so sudden and precise that they seem almost deliberate, as though the Earth is arranging them in patterns meant to be read. The relationship between fault lines and magnetic anomalies is intimate, a feedback loop that has persisted for millions of years. As tectonic plates drift apart, magma rises to fill the gaps. Iron-bearing minerals within the magma align with the Earth's magnetic field as they solidify. When a fault slips, these solidified deposits move, fracture, and twist, creating localized distortions. Over millennia, these small shifts accumulate, layering complexity onto the already intricate pattern of the Atlantic's magnetic signature. For explorers, this is both a challenge and an invitation. A compass in one spot may point true north. A few kilometers away, it may hesitate, drift, or swing sharply, mapping the invisible architecture of the seafloor below. Seismic activity further complicates the picture. Earthquakes along these faults, though often imperceptible at the surface, can reorient iron-rich rock, amplifying anomalies or creating entirely new zones of distortion. Historical records show that even small tremors in the mid-Atlantic ridge region cause compass readings on passing ships to fluctuate unpredictably. Observers reported subtle hesitations, needles pausing mid-swing, or pointing slightly off course for several hours. Modern instrumentation confirms that these micro-events produce measurable, localized magnetic disruptions, almost like ripples in an unseen field that flows above the seafloor. Yet the faults are not uniform, and the anomalies they produce vary widely. Some fractures generate long, linear magnetic corridors, stretching tens of kilometers in near-perfect alignment with the ridge. Others produce clusters of circular or spiral anomalies, complex zones where compasses and magnetometers behave erratically. In some cases, these patterns remain stable for decades, forming nearly permanent distortions. In others, they evolve over months or years, reflecting ongoing geological activity beneath the surface. This variability makes the Atlantic both a laboratory and a puzzle, predictable in its patterns, yet endlessly surprising in its details. The ocean itself interacts with these faults, amplifying or dampening anomalies depending on current flow, water density, and temperature. Deep water currents sweeping through fault valleys disturb magnetic readings, while thermaline layering can create subtle gradients that further complicate measurements. Hydrothermal vent plumes, rich in iron and other metals, add another layer of complexity, subtly shifting local magnetic fields as they disperse. Scientists attempting to map the anomalies must account for this interplay of geology, fluid dynamics, and magnetic physics, a challenge that continues to push the boundaries of oceanography and geophysics alike. Despite all these technical observations, the human response to these fault lines is no less profound. Sailors and researchers alike report an almost instinctive sense of unease when crossing high anomaly zones. Instruments may falter, yet compasses are not the only things that respond. Electronics can behave unpredictably. Subtle interference can affect communication lines, and even human perception seems to be influenced, as if the Earth itself whispers beneath the waves. It is a reminder that the faults are not merely structural. They are active participants in a hidden dialogue between the planet and those who attempt to observe it. Ultimately, the Atlantic's fault lines are more than geological features. They are dynamic, living conduits of history, memory, and energy. Each fracture, each ridge, each microslip contributes to the magnetic anomalies that have puzzled navigators for centuries. They are proof that beneath the calm surface, the Earth is alive, moving, breathing, and constantly rewriting its own record. And for those willing to listen, the patterns they leave behind are more than data. They are messages, echoes of the deep, and invitations to explore the Atlantic's hidden architecture in all its mysterious, powerful glory. The Atlantic's fault lines do more than merely fracture the crust. They sculpt the invisible architecture of the ocean itself. These deep fractures are not isolated features. but part of a sprawling network, a lattice that stretches from the mid-Atlantic ridge toward the abyssal plains. Within this lattice, magnetic anomalies do not merely exist. They migrate, fluctuate, and interact, forming zones of distortion that seem almost purposeful. The faults act as channels, guiding molten rock, directing mineral deposits, and shaping the local magnetic environment in ways that are only now beginning to be understood. Submersible missions have revealed the astonishing physical complexity of these regions. Towering basalt walls rise from the ocean floor, jagged and fractured like the spines of ancient creatures frozen in stone. Between these cliffs lie deep troughs where sediments collect, forming soft beds over hard rock. Within these troughs, hydrothermal activity deposits metals rich in magnetically sensitive minerals, creating local distortions in the magnetic field. The interaction between the faults and these deposits produces readings that are sometimes counterintuitive. A submersible hovering above a ridge may detect a strong positive anomaly, only to drift a few hundred meters into a null zone where the field collapses unexpectedly. Navigators and researchers alike are reminded that the magnetic environment here is a living, breathing system, not a static map. The faults themselves are dynamic. While the ridge spreads at a predictable rate mere centimeters per year, the fractures branching from it can slip suddenly, releasing stored strain energy. These microslips are often too subtle to register as earthquakes, yet they realign magnetic minerals, creating anomalies that appear overnight. Long-term monitoring has shown that some zones shift gradually over decades, producing magnetic pulses that drift in both intensity and orientation. These shifts can confuse even the most sophisticated instruments, and the patterns they produce often defy simple explanation. It is as though the Earth is writing in a language we can only partially decode, a script of molten rock and metal, preserved in the crust but constantly evolving. Hydrothermal vent systems intensify the complexity of the faults. Rich plumes of iron and other minerals rise from the seafloor, depositing layers that magnetize over time. The vents often occur in clusters along fractures, and their interaction with tidal currents and deep water flows further distorts the magnetic field. Instruments detect local pulses and gradients, often forming circular or spiral patterns that seem to echo the underlying topography. These anomalies are not only geological, but hydrodynamic in origin, influenced as much by water movement as by the shifting crust beneath. The human response to these conditions has always been one of awe and unease. Explorers report a tangible sense of disorientation in regions of high magnetic distortion. Compasses hesitate, magnetometers drift, and electronic systems register subtle interference. Early sailors had no instruments sophisticated enough to measure these effects, yet instinctively they felt the anomalies as a subtle pressure in the air, a small unease in the bones. Modern science confirms what they sensed. The faults are alive with energy, producing measurable effects that extend far above the seafloor. These anomalies also serve as archives of geological history. Each fracture, slip, and vent deposits layers of iron-bearing minerals that lock the magnetic orientation of the Earth into rock. By studying these formations, scientists can reconstruct the sequence of plate movements, eruptions, and micro-earthquakes over millions of years. The faults, therefore, are not merely present-day hazards or curiosities. They are living records of the Atlantic's violent and persistent evolution. Within their shifting planes lies the memory of the Earth itself, every pulse, every slip, every surge captured in the latticework of rock and magnetic flux. Yet, despite decades of research, there remain mysteries that defy understanding. Certain faults produce anomalies that cannot be traced to any known geological or hydrodynamic cause. Some regions exhibit pulsations, almost like a heartbeat, that repeat over periods too long or irregular to correlate with tides or plate movement. Others contain complex, spiral formations that suggest influences beyond conventional geology. These phenomena hint at forces not yet fully comprehended, reminding explorers that the Atlantic is not merely a passive backdrop, but an active, responsive system, capable of shaping both human perception and scientific measurement. The fault lines of the Atlantic are the veins of a living planet, carrying history, energy, and magnetic memory through the ocean's depths. They are at once a challenge to navigate, a record to interpret, and a conduit for forces that humans have only begun to detect. And as the ridge continues to spread, the fractures to shift, and the vents to deposit their minerals, the Atlantic's magnetic signature evolves, inviting those who observe it to follow deeper, measure closer, and witness the unseen machinery of the Earth in motion. As we trace the Atlantic's fault lines deeper, a broader pattern begins to emerge, one that links the seafloor's fractures to the ocean's hidden magnetic architecture. These faults, while localized in formation, are part of a vast interconnected network that stretches across the basin, forming conduits through which the planet's magnetic history flows. They are both pathways and barriers, guiding the flow of molten rock, influencing the deposition of iron-rich minerals, and shaping the very structure of the anomalies above. In this way, the faults are not merely passive features. They are active participants in a dialogue that has been ongoing for millions of years. The most striking evidence of this interplay comes from magnetic surveys conducted along the mid-Atlantic ridge and its adjacent fault systems. High-resolution magnetometers detect linear bands of alternating polarity, remnants of ancient geomagnetic reversals interspersed with zones of distortion produced by fault activity. These bands are not merely parallel lines on a chart. They are textured landscapes, twisted and folded by the movement of the crust. Where faults intersect, the patterns become complex, almost fractal, reflecting the chaotic, yet deeply ordered, processes shaping the ocean floor. Each fracture, each slip, each vent contributes to a living record that tells the story of Earth's internal rhythms. Submersible missions into these regions revealed the dramatic physicality behind the magnetic patterns. Jagged cliffs rise hundreds of meters from the abyssal plains, interspersed with deep troughs where sediment accumulates over eons. Hydrothermal vents erupt in bursts of mineral-laden plumes, depositing iron and other metals that subtly alter the local magnetic field. In some locations, the interaction of faults, currents, and vent activity produces anomalies of startling intensity, localized pulses that can deflect compasses and interfere with electronic instruments. The ocean becomes a dynamic laboratory, a place where geology, hydrodynamics, and magnetism intertwine. Earthquakes along these faults, even minor events, leave lasting imprints. A single slip can realign iron deposits, producing new anomalies or altering existing ones. Long-term monitoring has shown that some regions evolve over decades, with magnetic patterns shifting in response to ongoing tectonic activity. These changes are not random. They follow the movement of the crust and the underlying magma flows, reflecting the constant renewal and adjustment of the seafloor. In effect, the faults act as both canvas and brush, shaping the magnetic narrative of the Atlantic as it unfolds through time. The human experience of these fault zones is no less profound. Navigators report a sense of unease when crossing high anomaly areas, and scientists working with magnetometers and submersibles experience instrument readings that defy expectation. Compasses drift or hesitate, sensors register fluctuating intensities, and even sonar returns sometimes appear warped, producing echoes that suggest hidden structures. The ocean, in these moments, asserts itself not with violence, but with subtle insistence, reminding observers of the immense forces operating beneath the surface. Hydrothermal systems intensify this complexity. Vents deposit iron-rich particles into the water column, which then drift with deep currents, creating dynamic zones of magnetic distortion. The combination of fault-induced anomalies and vent-induced fluctuations produces patterns that are both intricate and ephemeral. Some anomalies remain stable over decades, while others fluctuate with the movement of currents, the deposition of minerals, or subtle shifts in the crust. The result is a seascape of magnetic texture as complex and layered as any terrestrial mountain range, hidden beneath kilometers of water. Yet even with modern instrumentation, mysteries persist. Certain faults exhibit anomalies that do not correlate with known geological or hydrodynamic processes. Some zones pulse rhythmically, as if following a heartbeat not of the human world, but of the planet itself. Spiral patterns, circular distortions, and localized magnetic storms challenge existing models, suggesting forces and interactions yet to be understood. These enigmatic features remind researchers that the Atlantic is not a static laboratory, but a living, responsive system, one that continues to evolve in ways both measurable and unknowable. By the end of this exploration, it becomes clear that the faults of the Atlantic are more than geological fractures. They are conduits of memory, energy, and motion. They encode the history of the ocean's formation, the shifting of tectonic plates, and the pulsations of the planet's magnetic field. They influence navigation, guide the deposition of minerals, and shape the experiences of all who venture above or below them. They are living architecture, as vital to understanding the Atlantic as the water that covers them, a testament to the deep, hidden power of the Earth itself. The anomalies of the Atlantic are unlike any other phenomena on Earth. They are neither storms nor tides, nor the predictable swells of currents. They are subtle and visible distortions, fluctuations in the magnetic field that ripple across the ocean with a deliberate, almost conscious precision. To the casual observer, the sea appears calm, a flat expanse of gray and blue. But beneath the surface lies a network of forces so intricate that they challenge every expectation of order, a labyrinth of energy woven into the very crust of the planet. Early observers mistook these anomalies for error or coincidence. Sailors in wooden ships noticed compasses hesitating or veering for no discernible reason. Navigational charts failed to align, and instruments that should have been reliable betrayed their operators in small, unnerving ways. At first, these occurrences were dismissed as mechanical faults, the result of poorly calibrated equipment or simple human error. But as reports accumulated, patterns emerged: locations where instruments consistently faltered, corridors where compasses drifted, zones where readings swung violently before snapping back. It became impossible to ignore the signs. The anomalies are not uniform. Some are linear, stretching along fault lines and ridges, predictable in their orientation, but unpredictable in their intensity. Others are irregular, clustered, or circular, forming spirals that seem to echo some hidden rhythm beneath the seafloor. Each anomaly carries its own signature, a combination of intensity, polarity, and fluctuation that can vary over decades, months, or even days. It is as if the ocean itself has a language, one written in magnetic pulses, and every anomaly is a word, a sentence, a fragment of a message left by forces far older than human understanding. Hydrothermal vents, rich in iron and other minerals, amplify these anomalies. Rising from the depths, their plumes deposit layers of magnetically responsive material, subtly altering the local field. The resulting distortions create zones of interference that can mislead compasses, magnetometers, and even sonar equipment. Instruments passing through these zones detect rapid shifts in intensity, sometimes strong enough to produce measurable currents in sensitive electronics. For those studying the anomalies, the ocean becomes a dynamic environment, simultaneously a subject of research and a living entity that resists easy measurement. Seismic activity plays a similarly transformative role. Fault lines that shift even minutely can realign iron deposits, producing new anomalies or altering existing ones. Over centuries, repeated movements compound, creating a complex tapestry of magnetic signatures that reflect both past and present activity. Scientists now recognize that these anomalies are not static. They are evolving phenomena, recording geological events as they occur, leaving behind traces of earthquakes, volcanic eruptions, and the slow, inexorable drift of tectonic plates. Each anomaly is a living archive, a snapshot of forces in motion. The human experience of these anomalies has always been marked by awe and unease. Sailors describe a subtle disorientation when crossing high anomaly zones, a feeling that the horizon is slightly askew, that instruments are betraying reality. Modern researchers encounter similar phenomena. Compass needles hesitate or drift. Magnetometers register fluctuations beyond expectation, and electronic sensors sometimes behave unpredictably. Even sonar returns, normally reliable, can produce strange, fractured echoes. The ocean communicates, not with noise or force, but with a quiet insistence that the anomalies are real, deliberate, and significant. Some anomalies are isolated. Others interact, creating chains or networks that stretch across hundreds of kilometers. In these interconnected regions, small shifts in one location can propagate changes across distant anomalies, producing a cascading effect that challenges understanding and prediction. It is a reminder that the anomalies are not random defects, but components of a system one governed by principles of geology, hydrodynamics, and electromagnetism that are deeply intertwined. Observers feel the subtle power of this system, its ability to influence both instruments and perception. Even as science advances, mysteries remain. Certain anomalies do not correlate neatly with known fault lines or hydrothermal activity. Some display pulsations that seem rhythmic, almost like a heartbeat, while others twist in spirals or loops that defy current models. These features suggest forces and interactions yet to be discovered, hinting at a complexity that is both humbling and exhilarating. To witness them is to glimpse the Atlantic as it truly is, not merely a body of water, but a living, dynamic entity whose invisible forces shape every journey across its surface. The anomalies are the Atlantic's signature, a language written in iron, rock, and flowing energy. They are both warning and invitation, evidence of immense, unseen forces, and an open challenge to understand them. They remind us that beneath the placid waves, the planet's inner life is constantly active, and that the world's most subtle phenomena can be among the most profound. As explorers delved deeper into the Atlantic's hidden corridors, it became clear that anomalies were not random quirks of the Earth's magnetism, but markers of a grand, interconnected system. The linear anomalies stretching along the mid-Atlantic ridge and its branching faults were the most predictable, yet even they defied full understanding. Instruments passing over these corridors registered sharp deflections, subtle pulses, and sudden lulls that sometimes extended for kilometers. To the trained eye, these patterns were neither chaotic nor accidental. They were signatures of the Earth's internal machinery, written in stone, iron, and invisible currents. The interplay between hydrothermal vents and tectonic fractures further complicated the narrative. Vents discharge mineral-rich plumes, laden with iron and other magnetically susceptible elements. As these particles settle onto the seafloor, they gradually alter the local magnetic environment, producing anomalies detectable long after the vent's eruption has subsided. In some cases, these deposits form intricate, spiral-like patterns twisting around fault lines and creating zones of highly localized magnetic intensity. For navigators and researchers alike, these features were simultaneously beautiful and disorienting, a physical manifestation of the planet's invisible forces. Seismic activity adds yet another layer to the anomaly's complexity. Minor shifts in fault lines, sometimes imperceptible at the surface, can realign magnetized rock deposits, generating sudden, unpredictable distortions. These micro-earthquakes, repeated over centuries, layer complexity upon complexity, producing anomalies that shift subtly over time. When mapped in high resolution, the Atlantic's magnetic field reveals a dynamic mosaic linear streaks, spirals, localized spikes, and even small voids where the field seems inexplicably absent. Each feature is a record of geological history, capturing both the slow drift of tectonic plates and the instantaneous release of seismic energy. In addition to geological processes, the ocean itself mediates the anomalies. Deep currents sweep through fault valleys, carrying mineral particles and influencing local magnetic fields. Tourmaline layering creates subtle gradients in conductivity and density, affecting the propagation of magnetic pulses. Instruments passing through these zones detect fluctuations that may appear ephemeral, yet they are precise indicators of the ongoing interactions between geology, water, and magnetism. In this way, the Atlantic is a multi-layered laboratory where forces of different scales converge to produce patterns that are both measurable and mysterious. Human observers continue to report uncanny experiences near high-intensity anomalies. Sailors have long described a sensation of imbalance or subtle disorientation, a feeling that the horizon tilts imperceptibly and instruments rebel without cause. Modern researchers, while equipped with sensitive magnetometers and submersibles, often witness the same phenomena. Compasses hesitate or swing erratically, electronic sensors fluctuate unpredictably, and sonar returns sometimes fragment, producing echoes that suggest invisible structures. These experiences reinforce the idea that anomalies are not just scientific curiosities, but active expressions of the Atlantic's inner life, capable of influencing both matter and perception. Some anomalies exist in isolation. Others interact across great distances. When clusters align, a disturbance in one area can ripple through connected zones, creating cascading magnetic effects that challenge prediction. These networks reveal that the anomalies are part of a broader system-wide process, one in which tectonics, hydrothermal activity, mineral deposition, and deep water dynamics are intertwined. Observers begin to sense a rhythm, subtle yet persistent, a flow of energy and information coursing along the fractures beneath the waves. The Atlantic, in this sense, is not a passive ocean but a responsive organism, its anomalies acting as the visible trace of its internal processes. Yet despite decades of research and mapping, the most enigmatic anomalies remain unexplained. Certain regions display pulsations that suggest an almost deliberate periodicity, as if the Earth itself were signaling in beats too slow for human timekeeping. Spiral anomalies twist with precision that defy simple geological explanation. Void zones appear where instruments register little to no magnetic influence, disrupting otherwise consistent patterns. These features hint at forces and interactions that remain beyond current understanding, reminding scientists that even with modern technology, the Atlantic retains aspects of profound mystery. The anomalies, in their subtlety and power, are both the Atlantic's signature and its warning. They chart the unseen forces beneath the waves, recording geological history, guiding navigation, and influencing perception. They are invitations to explore further, to measure more precisely, and to recognize that the ocean's most profound messages are written not in visible waves but in the invisible pulse of the Earth itself. Every anomaly is a fragment of a story, a whisper from the depths, a challenge to understand a world that is alive, dynamic, and far older than humanity's brief presence upon it. The deeper one ventures into the Atlantic's magnetic labyrinth, the more the anomalies reveal their uncanny sophistication. Some appear as subtle wavering corridors, guiding compass needles with a delicate insistence, almost as if they are invisible highways etched into the ocean floor. Others are abrupt, isolated spike-short bursts of intensity that defy expectation, appearing suddenly over just a few hundred meters. For explorers, these are the places that test both instruments and nerves, zones where readings become erratic, where digital sensors falter, and where the familiar rules of navigation feel suspended. It is here that the anomaly's presence becomes almost tactile, a silent force felt as much as measured. Mapping these features has been a pursuit of decades, one that combines technological ingenuity with meticulous observation. Remote-operated vehicles sweep magnetometers along the seafloor, logging thousands of readings per square kilometer. Submersibles hover above deep valleys, tracing faults and ridges while monitoring minute variations in the local field. Every anomaly is cataloged, its shape, intensity, and orientation recorded in exhaustive detail. Yet the more complete the map becomes, the more complex it appears. The anomalies are not uniform. They interact, overlap, and evolve, producing a three-dimensional web of influence that stretches across hundreds of kilometers and several kilometers of depth. It is a living network, dynamic and unyielding. Hydrothermal activity remains one of the principal architects of this complexity. Vents, often clustered along fracture zones, spew mineral-rich plumes that settle in intricate, sometimes spiraling patterns across the seafloor. Iron, manganese, and other magnetic elements align subtly with the Earth's field, gradually modifying the local magnetic signature. Over time, these deposits can enhance existing anomalies or create entirely new zones of distortion. The interaction of vent activity with underlying tectonics and fault-driven shifts produces anomalies that are both precise and ephemeral, persistent enough to detect, yet constantly evolving, challenging the observer to distinguish temporary perturbations from long-term features. Seismic events, from microquakes to moderate tremors, also leave lasting imprints on the magnetic landscape. Even small shifts along a fault can realign mineral deposits, subtly altering field orientation. When multiple shifts occur over centuries, the accumulated changes produce anomalies of remarkable complexity. Twisted corridors, overlapping fields, and zones that pulse with intensity fluctuations that seem almost rhythmic. These layered distortions act as geological fingerprints, encoding the history of the seafloor with each tremor, eruption, and movement. For scientists, reading these fingerprints is like deciphering a language written in stone and energy, a script that spans millions of years. Human perception continues to respond to these anomalies in ways both subtle and profound. Sailors crossing high-intensity zones report a feeling of imbalance or vertigo, a small but undeniable unease. Modern researchers confirm these sensations. Compass needles hesitate, electronic devices fluctuate, and even sonar systems produce fractured echoes. The ocean, it seems, communicates through these anomalies not with sound or motion, but through fields of force that reach upward from the depths, influencing the very tools humans use to navigate and explore. It is a reminder that the Atlantic is not passive. It is an active, living presence, asserting itself quietly, yet unmistakably. Some anomalies interact across vast distances, forming chains or networks that produce cascading effects. A subtle shift in one fault can ripple outward, altering magnetic fields hundreds of kilometers away. These interactions suggest a level of coordination in the anomalies, a deep underlying system that is both orderly and unpredictable. Observers begin to perceive rhythm, a subtle pulse that weaves through the lattice of faults, vents, and mineral deposits, a heartbeat too slow and vast for human eyes, yet detectable in instruments sensitive enough to capture it. The anomalies, in this sense, are not isolated oddities. They are the visible threads of a hidden circulatory system, the Atlantic's way of encoding its internal energy and history. Yet the anomalies retain their deepest mysteries. Certain regions defy explanation entirely. Some pulse with regularity, as if following a hidden cycle. Others form tight spirals, loops, or voids that appear disconnected from any known geological or hydrodynamic process. These enigmatic features suggest forces beyond conventional science, reminders that the Atlantic is more than a collection of rocks and water, It is a living archive, a dynamic system capable of producing patterns that challenge comprehension. To study these anomalies is to witness a dialogue between the Earth and the ocean, one that stretches across time and depth, and one that humanity has only begun to interpret. The anomalies are both the Atlantic's signature and its language. They are a record of the Earth's shifting crust, a map of energy flowing unseen beneath the waves, and a testament to the ocean's living complexity. Each pulse, spike, and spiral tells a story of motion, time, and force. And for those who navigate, measure, or simply observe, they are invitations to explore further, to understand deeper, and to recognize that the Atlantic, with all its calm surfaces, is a dynamic, breathing entity, writing its history in patterns both visible and invisible. The most confounding anomalies of the Atlantic do not announce themselves with sweeping signatures or predictable pulses. They emerge quietly, in isolated pockets, only to reveal themselves when instruments or explorers happen upon them. These anomalies are subtle, yet intense, localized distortions that can skew readings over a small but critical area. For navigators and researchers, encountering one can feel like stepping into a zone where the rules of the familiar world are suspended, where compasses falter, magnetometers waver, and even electronic instruments behave unpredictably. It is as if the ocean itself is asserting its presence, reminding observers that its hidden currents of force are vast, ancient, and complex beyond ordinary comprehension. Mapping these elusive zones has challenged scientists for decades. High-resolution surveys revealed that anomalies vary not only in intensity but in structure. Some form long linear corridors along fracture zones. Others curve into spirals or clusters of localized spikes. Still others appear as voids, areas with no measurable magnetic influence where one would expect continuity. These patterns often overlay one another, creating intricate mosaics that shift subtly over time. The more researchers study these anomalies, the more they recognize their dual nature, both predictable in their alignment with geological features and unpredictable in their local behavior, a paradox that underscores the depth of the Atlantic's hidden systems. Hydrothermal vents contribute to these anomalies in profound ways. Mineral-rich plumes from these vents deposit iron, manganese, and other magnetically active elements along the ocean floor. Over time, these deposits create magnetic distortions that can intensify or modify the anomalies already present. When currents sweep through these plumes, the effects extend beyond the immediate vent area, producing dynamic changes in local fields that can persist for years. The interaction between these vent-induced changes and underlying tectonic activity forms a complex, interdependent system, a web of cause and effect that spans kilometers and decades, continuously rewriting the magnetic landscape. Seismic shifts along fault lines further complicate the anomaly's behavior. Even minor tremors, imperceptible at the surface, can realign magnetized minerals, creating sudden spikes or subtle shifts in intensity. Over centuries, repeated activity layers complexity upon complexity, producing patterns that defy simple classification. When anomalies are mapped over time, their evolution appears almost organic. Zones that were once weak may intensify, others may shift position, and new anomalies may emerge where none existed before. The Atlantic's magnetic field in these regions is less a static map and more a living tapestry, continuously shaped by the interplay of tectonics, hydrothermal deposits, and fluid dynamics. Human experience in these zones often echoes the subtle, pervasive influence of the anomalies. Sailors have long reported feelings of unease, disorientation, or even vertigo when crossing high-intensity areas. Researchers using submersibles or magnetometers experience equipment anomalies that cannot be explained by mechanical failure alone. Compass needles hesitate, instruments fluctuate, and sonar returns sometimes appear fragmented or distorted. These experiences reveal a profound truth. The Atlantic is not a passive body of water, but an active, responsive system, capable of affecting both matter and perception. The anomalies, in this sense, are both measurable phenomena and lived experience, bridging the gap between scientific observation and human intuition. In some regions, anomalies interact across great distances, forming chains of distortion that propagate along fault lines or through mineral-laden currents. A subtle shift in one location may trigger cascading effects in distant areas, producing complex, interconnected patterns. These networks suggest an underlying order, a rhythm or circuitry that humanity has only begun to recognize. Researchers describe this as a kind of hidden language, a pattern of magnetic dialogue stretching across the seafloor, one that encodes the movements of the crust, the flow of magma, and the distribution of minerals over millennia. And yet, despite decades of study, the anomalies retain their most profound mysteries. Certain zones pulse with an almost rhythmic intensity, spiraling in ways that defy conventional explanation. Others appear as gaps or voids, breaking the continuity of the field in unexpected ways. These enigmatic features hint at forces not yet understood, at processes that extend beyond the reach of current instrumentation. The Atlantic, it seems, preserves secrets even as it reveals patterns, challenging explorers to measure, map, and comprehend a system far more intricate than surface observation alone can capture. By the close of this chapter, it becomes clear that the anomalies are not mere curiosities. They are the Atlantic's signature, a language of force and memory written across the ocean floor. Each distortion, pulse, and spiral records geological history, encodes the movement of tectonic plates, and signals the presence of forces beyond ordinary perception. To study them is to witness the Atlantic's hidden life, to engage with its subtle but pervasive power, and to understand that beneath the calm, gray waves lies a world alive with energy, motion, and endless mystery. The Atlantic's dark faults are a world apart from the surface waters above, a shadowy labyrinth of rock, pressure, and ancient energy. Here, light has no place. Even the strongest submersible lamps pierce only a fraction of the surrounding blackness, revealing vertical walls of basalt that rise like cliffs in a subterranean canyon. The water is dense and cold, carrying the weight of thousands of meters above, a silence broken only by the distant echoes of the ocean floor. Within these hidden corridors, the faults converge, twist, and split, forming channels that have remained largely uncharted for millennia. It is a place of patient, relentless movement, where the planet's internal forces are laid bare. The magnetic anomalies intensify in these depths. Compasses and magnetometers behave unpredictably, swinging, hesitating, or even locking momentarily in defiance of human expectation. The faults themselves are conduits for energy, guiding iron-rich deposits and the subtle currents of the Earth's magnetic field along their fractures. Each twist of the fault, each shift of rock, reshapes the invisible architecture of force that floats above the seafloor. For explorers, these distortions are not merely data points. They are tangible markers of a world operating under rules both ancient and precise, a world in which the Earth's inner life pulses with quiet insistence. Submersible expeditions into these corridors have revealed structures that seem almost deliberate. Towering basalt spires rise like monoliths, their faces etched with striations that record millions of years of tectonic pressure. Narrow canyons descend into darkness, carrying sediment and mineral deposits that subtly shift the magnetic field. Hydrothermal vents dot the landscape, releasing plumes of iron and other metals that drift with the slow, cold currents. These deposits, over time, create localized anomalies so sharp that passing instruments can register sudden spikes in intensity, followed by zones of eerie calm. The faults themselves act as both stage and performer, shaping the unseen forces that animate the ocean around them. Seismic microvents add yet another layer of dynamism. Tiny shifts in the rock, often imperceptible at the surface, can realign iron-rich minerals, producing abrupt but localized anomalies. Over centuries, these small shifts accumulate, creating magnetic distortions that are as intricate as any natural pattern. In some places, the faults seem to breathe subtle cyclical changes in the magnetic field detectable by sensitive instruments, pulsing in rhythms too slow to perceive in human time, but precise over geological scales. For scientists, these observations hint at a deep intelligence in the Earth's processes, not conscious, perhaps, but deliberate in its logic, a system of cause and effect measured in millennia rather than minutes. Navigating these dark faults is a challenge that blends science, technology, and intuition. Submersibles must move slowly, carefully, mapping every ridge and trench while accounting for magnetic distortions that could mislead instruments. Every measurement is a negotiation with the environment. The faults are alive with energy, subtly influencing the tools designed to observe them. Hydrothermal plumes can obscure readings, currents can shift deposits, and minor tremors can alter the landscape without warning. Yet within these constraints, explorers find patterns, linear alignments along fractures, clusters of anomalies near vent fields, and spirals where the Earth's magnetic memory loops upon itself. It is a hidden architecture, invisible to the eye but as real and enduring as the rock itself. Even human perception is shaped by the environment. Deep in the faults, the absence of light and the presence of subtle electromagnetic distortions create an atmosphere of dislocation. Observers report a quiet vertigo, a sense that space itself has warped. Instruments may hesitate or fluctuate, and visual cues from the submersible can seem distorted by the interaction of light, shadow, and water density. It is a reminder that the Atlantic's dark faults are not just geological formations. They are environments capable of shaping every aspect of observation, of bending both data and perception into forms that reflect the immense, unseen forces at work. Yet these depths are not static. Over centuries and millennia, the faults shift, stretch, and grow, releasing energy in ways that are both subtle and profound. The mineral deposits that form hydrothermal plumes drift with currents, modifying the magnetic field. Micro-earthquakes realign rock. Slowly moving tectonic plates expand and contract, subtly reshaping corridors that may have existed for millions of years. In every movement, the faults write a living record, one that is both visible in anomalies and invisible in the currents of energy that pass silently above them. Here, beneath kilometers of water and beneath the calm surface of the Atlantic, the planet's inner life is tangible, vast, and humbling, a reminder that the Earth is more than the sum of its continents, seas, and skies. It is a dynamic, breathing entity, and the dark faults are its veins. Descending further into the dark faults, the Atlantic reveals a complexity that challenges both imagination and instrument. Narrow canyons wind between basalt cliffs, often descending at angles so steep that the ocean floor below disappears into blackness. Sediments have accumulated over millennia, softening the edges of jagged rock. Yet even this sediment is layered with iron and magnetically active minerals, each particle subtly influencing the field above. Instruments passing through these corridors register fluctuations that are immediate and localized, spikes and voids that shift with the currents, the tides, and the unseen tremors of the Earth itself. Hydrothermal vent fields are especially concentrated along these faults, their plumes of mineral-rich water rising like ghostly fingers into the surrounding darkness. Iron, manganese, and other magnetically active elements settle onto the fault walls and seafloor, creating zones of sharply defined anomalies. These deposits interact with the underlying crust in unpredictable ways, sometimes amplifying the anomalies produced by fault shifts, sometimes damping them in subtle, nearly imperceptible ways. It is a delicate balance, a dance of energy and matter that has persisted for millions of years, shaping the magnetic signature of the Atlantic without human awareness. Seismic microevents continue to leave their mark. Even tremors too small to register at the surface realign magnetized minerals, creating instantaneous, transient distortions in the field. Over time, these small changes accumulate, layering anomalies in a complex three-dimensional mosaic. Some zones appear stable, persisting over decades, while others evolve rapidly, shifting orientation or intensity in response to tectonic activity. For explorers and scientists, this is both a challenge and a revelation. The dark faults are not static structures, but dynamic, living corridors of energy and information. The interaction of currents with the faults adds yet another layer of complexity. Deep water flows, moving slowly yet powerfully, disturb sediments carrying mineral particles, and interact with hydrothermal plumes, subtly modifying the magnetic field. Thermal gradients, differences in temperature and salinity, create additional variations in conductivity, influencing the propagation of magnetic anomalies. Observers must account for all these factors, piecing together a picture from a constantly shifting array of signals. The ocean here is not merely a medium but an active participant, its movement shaping the anomalies as much as the faults themselves. Human perception in the dark faults is shaped by these invisible forces as well. Deep in the abyss, instruments may hesitate, needles may drift, and electronic equipment may fluctuate unpredictably. Explorers report sensations of disorientation, subtle vertigo, or an unshakable sense of being observed by the environment itself. The faults are not simply obstacles to navigation. They are active, responsive systems that influence both measurement and experience. Each anomaly, each pulse of magnetic energy, reinforces the sense that the Atlantic's depths are a world governed by its own rules, vast, ancient, and unknowable. Within these corridors, explorers also encountered geological formations that hint at the ocean's violent past. Basalt spires rise from the depths like frozen sentinels, etched with striations recording eons of tectonic stress. Sediment layers reveal repeated cycles of deposition, erosion, and hydrothermal activity. In some areas, the faults converge, forming junctions of remarkable complexity where anomalies intensify, spiral, and interact in ways that seem almost deliberate. It is as though the Earth has left a signature here, one that can be read only by instruments attuned to its subtle language. Yet, even with all this observation, much remains mysterious. Some anomalies pulse rhythmically, almost like a heartbeat, yet with periods so long they escape casual detection. Spiral formations twist in ways that resist conventional geological explanation. Void zones appear where the magnetic field seems absent, defying the otherwise continuous patterns. These phenomena hint at forces that operate beyond the reach of current understanding, a reminder that the Atlantic's dark faults are not simply geological features, but dynamic, living systems. They preserve secrets, encode histories, and challenge explorers to comprehend their hidden logic. In the end, navigating the dark faults is a test of endurance, perception, and interpretation. The anomalies, hydrothermal deposits, and tectonic movements converge to form an environment that is both treacherous and mesmerizing. It is a world where the unseen dominates the seen, where subtle forces shape perception and measurement alike, and where the Atlantic reveals itself not as a static ocean, but as a vast living system, its veins and arteries pulsing beneath the waves, invisible yet profoundly real. Venturing even deeper into the Atlantic's dark faults, the environment grows increasingly alien. Here, the crushing weight of thousands of meters of water presses down, compressing every sound, every movement, and every particle into an almost timeless stillness. Light is non-existent beyond the narrow beams cast by submersibles, and even these beams reveal only fragments of the towering basalt walls that flank the faults. The terrain is jagged and unpredictable, a twisted network of ridges, trenches, and spires shaped over millions of years by tectonic pressures, volcanic activity, and a relentless flow of the Earth's internal energy. It is in this silence and darkness that the magnetic anomalies reveal their most astonishing behaviors. The anomalies intensify in these deep corridors. Compasses and magnetometers exhibit swings so sharp they appear intentional, needles hesitating, oscillating, or even locking momentarily as though resisting interpretation. These shifts are not random. They correlate with the alignment of fault structures, the deposition of mineral-rich sediments, and the presence of hydrothermal plumes. The faults act as channels for magnetic energy, guiding it along predictable paths while simultaneously producing turbulence where the crust is shifted or fractured. Each anomaly becomes a living map, recording the history of the Earth's movement, the deposition of iron and other minerals, and the interaction of energy and matter across millennia. Hydrothermal activity plays a particularly vital role in shaping these anomalies. Vents spew mineral-rich water in bursts that rise like ghostly towers, depositing iron, manganese, and other magnetically active materials along the walls and floors of the faults. These minerals gradually magnetize in alignment with the Earth's field, intensifying or creating localized anomalies. The plumes themselves interact with deep currents, dispersing minerals over distances and producing transient distortions that overlay the permanent features etched into the seafloor. In essence, the ocean's currents become both the medium and the sculptor, modifying the magnetic environment continuously. Seismic micro-events contribute further complexity. Tremors, often imperceptible on the surface, can realign magnetized rock, producing sudden spikes or shifts in the local field. Over centuries, repeated microshifts accumulate, layering anomalies upon anomalies in a complex, three-dimensional lattice. Observations reveal zones of intricate spirals, overlapping fields, and transient pulses that seem to move almost like waves through the deep corridors. For scientists, these patterns are simultaneously frustrating and mesmerizing. The faults appear to record their own histories, a geological diary written in magnetic flux, waiting for interpretation. Human perception in these depths is profoundly affected by the anomalies. Sailors, even in earlier centuries, noted subtle unease when passing over high anomaly zones. Modern explorers in submersibles experience compass needles hesitating, instrument readings fluctuating, and even the faint impression that space itself has subtly warped. It is as though the faults are active participants in observation, influencing not only the instruments, but also the observer's sense of orientation. The environment is both physical and psychological, a reminder that the Atlantic's depths shape human experience as much as they record it. Some anomalies extend across vast distances, forming networks that ripple through the faults. A shift in one area can propagate, influencing distant zones in ways that are detectable with sensitive instrumentation. These interactions suggest that the anomalies are part of a larger system, one in which tectonics, hydrothermal processes, mineral deposition, and ocean currents interconnect across kilometers and centuries. Observers begin to sense a rhythm, a pulse, a subtle order beneath the apparent chaos. The anomalies, in effect, are the Atlantic's heartbeat, a record of energy flowing beneath the waves. Yet mystery persists. Certain anomalies pulse with slow, deliberate regularity. Others form spirals or loops that seem to defy known physics, and void zones appear where the magnetic field inexplicably disappears. These phenomena hint at processes beyond current understanding, reminding explorers that even in an age of advanced technology, the Atlantic's dark faults retain secrets. They are not static corridors, but living systems, dynamic and responsive, shaped by forces both visible and invisible. By the end of this descent, it becomes clear that the dark faults are the Atlantic's hidden veins, conduits of energy, history, and motion. They are environments where light is absent, yet knowledge is present, where silence dominates, yet forces speak, where human perception and scientific measurement converge, challenged by the immense, subtle power of the deep ocean. Within these corridors, the planet's internal life is revealed alive, intricate, and impossible to ignore. As explorers reach the deepest reaches of the dark faults, the Atlantic transforms into a realm that feels almost otherworldly. Here, the faults converge into vast networks, twisting and intersecting with a complexity that defies conventional mapping. The basalt walls rise like monolithic sentinels, fractured and striated by eons of tectonic pressure. Sediments, laden with iron and other magnetically active minerals, cover the fault floors, adding another layer of influence over the ever-shifting magnetic environment. The sheer weight of the ocean above amplifies the isolation of this realm, where the only sounds are the faint hum of equipment and the distant echoes of microseismic activity. Magnetic anomalies reach their peak intensity in these deep corridors. Instruments can no longer rely on simple linear readings. Compasses hesitate, swing wildly, or lock in one direction before abruptly shifting. Magnetometers record sudden spikes and null zones that appear and vanish over short distances. These fluctuations are shaped by the interplay of fault geometry, hydrothermal mineral deposits, and subtle tectonic adjustments. Every anomaly tells a story, a record of microquakes, hydrothermal eruptions, sediment shifts, and the slow, relentless expansion of the Atlantic's crust. It is a language written in force, invisible yet powerful, and decipherable only to those willing to probe its depths with patience and precision. Hydrothermal vents continue to sculpt the anomalies with meticulous subtlety. Plumes rise from fissures in the seafloor, laden with iron, manganese, and other magnetic minerals. As these materials settle, they reinforce existing magnetic features or create entirely new distortions. Currents distribute these deposits across fault valleys, producing transient pulses that interact with the underlying crust. The anomalies are thus both enduring and ephemeral, a combination of ancient geological memory and immediate environmental response. Scientists navigating these zones must constantly adjust their readings, aware that every measurement is influenced by a confluence of forces, both predictable and unknowable. Seismic microevents add another layer of complexity. Small tremors, often imperceptible from the surface, realign magnetic minerals, producing sudden localized distortions. When observed over centuries, these small shifts accumulate, creating spirals, loops, and overlapping anomalies that form a three-dimensional lattice. The deep faults act as both canvas and archive, capturing the planet's internal rhythms in a record that is at once physical and dynamic. For researchers, this is both a challenge and a revelation. The ocean floor here is not merely rock, but a living repository of energy, memory, and motion. Human perception is uniquely affected in these extreme environments. Even experienced explorers report subtle disorientation, a sense that space itself has shifted, compounded by the erratic behavior of instruments. Compasses hesitate, needles drift, and sonar signals can fragment or bend unexpectedly. The ocean communicates not with sound or motion, but through invisible fields that shape experience and measurement alike. In the dark faults, the Atlantic asserts itself in a way that is as psychological as it is scientific, forcing humans to recognize the profound scale and subtlety of its internal forces. Some anomalies stretch across enormous distances, forming networks where a subtle change in one location can propagate across kilometers. These interactions suggest a system of hidden connectivity, a vast lattice through which magnetic energy flows, linking faults, vents, and fractures into a coherent though invisible architecture. Observers begin to sense patterns within this complexity, a rhythm, a cadence, a subtle pulse that hints at the underlying order of a system far larger than any individual fault or vent. The Atlantic, in this sense, is alive, communicating through the interplay of magnetic and geological processes across vast scales of time and space. Yet mystery persists in the deepest recesses. Certain anomalies display rhythms that are almost deliberate, Spiral formations twist with enigmatic precision, and voids appear where the field seems absent. These phenomena hint at forces or interactions still beyond scientific understanding, emphasizing that the dark faults are not just geological formations, but dynamic, living systems. They are archives of motion, energy, and history, constantly evolving and interacting in ways that challenge even the most advanced instrumentation. By the end of this descent into darkness, it becomes clear that the faults are not merely fractures in the crust. They are the veins of a living Atlantic, conduits of energy, memory, and motion. They record the planet's history, shape the present, and influence every observer who ventures into their depths. In this hidden realm, the ocean is more than water. It is an active, breathing force, writing its story in anomalies that endure across eons, yet remain alive and ever-changing beneath the waves. The Atlantic's hidden forces do not vanish when the faults fade from sight. Instead, they echo outward, weaving a subtle network of influence across the ocean's vast expanse. Magnetic anomalies, hydrothermal plumes, and tectonic shifts ripple through the deep waters, leaving traces detectable far from their origins. These echoes are not audible in the conventional sense. They are felt in the hesitation of a compass needle, in the unpredictable readings of a magnetometer, and in the quiet, unspoken awareness of those who traverse these waters. The Atlantic speaks, and it does so in vibrations of energy that transcend human time and scale. Even at the surface, the effects of the hidden Atlantic can be sensed. Navigators charting these waters often experience zones where instruments falter, where electronic systems behave erratically, or where compasses seem to resist alignment. These anomalies are the surface manifestation of the complex interactions taking place deep below. The twisting of faults, the deposition of minerals by hydrothermal vents, the slow pulse of tectonic plates as they drift across the seafloor. What is unseen is not absent. It resonates, influencing the world above with a quiet but persistent power. The interplay of geology and magnetism creates patterns that are at once mesmerizing and elusive. Linear anomalies trace fault lines, spirals form over vent fields, and void zones punctuate the ocean floor where energy disperses unpredictably. Together, these features form a lattice of force, a hidden topography that cannot be seen, only measured and interpreted. For scientists, mapping this invisible landscape is both a technical challenge and an intellectual revelation. Each measurement, each pulse, each anomaly reveals a story written in the language of the Earth itself. Hydrothermal systems continue to leave their mark, even after the vents cease activity. Deposited minerals remain aligned with the Earth's magnetic field, influencing local anomalies for decades or centuries. The currents carry these deposits, dispersing them across fault valleys and deep canyons, producing transient distortions that appear and vanish like echoes of past events. In this way, the Atlantic becomes a living memory, a dynamic archive in which every movement, eruption, and shift leaves a subtle but enduring trace. The ocean preserves the past in a language invisible to the eye, yet unmistakable to the instruments designed to detect it. Seismic events, from minor tremors to more substantial quakes, amplify these echoes. Each movement of the crust realigns mineral deposits, alters the structure of faults, and produces cascading anomalies that radiate outward. Over time, these events layer complexity upon complexity, creating a three-dimensional web of magnetic fluctuations that record the planet's geological history. In this hidden network, anomalies are not isolated phenomena. They are part of a continuum, interconnected and evolving, reflecting both the immediate present and the distant past. Human experience in these zones continues to mirror the subtle influence of the hidden Atlantic. Sailors and researchers alike report sensations of disorientation, vertigo, or unease when passing over areas of high-intensity anomalies. Instruments hesitate or fluctuate, and even advanced electronic systems can produce readings that defy expectation. These experiences underscore a profound truth. The Atlantic is more than water, currents, and weather. It is a living, breathing system whose hidden forces shape the environment, influence perception, and extend far beyond the visible horizon. Some anomalies form networks that connect across hundreds of kilometers, demonstrating a level of coherence and interdependence that is both elegant and enigmatic. Shifts in one fault or vent field can ripple through distant zones, producing magnetic changes that propagate far from their origin. Observers begin to perceive rhythm in the patterns, a subtle cadence that hints at an underlying order. These echoes suggest that the Atlantic's hidden architecture is not random, but structured, a system that communicates its history, energy, and motion across vast scales of space and time. Yet mystery remains in even the most studied regions. Certain anomalies pulse with a slow, deliberate intensity, spiraling in ways that defy current understanding. Void zones appear unpredictably, interrupting otherwise continuous fields. These phenomena hint at forces and interactions that remain beyond scientific reach, suggesting that the Atlantic preserves secrets as much as it reveals them. Its echoes are a reminder that despite all observation, the ocean retains a hidden life, a subtle but profound force that shapes the world above and below in ways only beginning to be understood. By the close of this first part, it becomes clear that the hidden Atlantic is not a passive stage, but a dynamic participant. Its anomalies, magnetic distortions, and hydrothermal deposits are more than data points. They are the voice of a living ocean, recording its history, influencing perception, and transmitting its power far beyond the immediate environment. To witness these echoes is to engage with the Atlantic not merely as a body of water, but as a vast, intricate system, alive with movement, memory, and energy. The echoes of the hidden Atlantic extend beyond immediate observation, traveling unseen through the ocean's vast interior. Currents carry subtle pulses of magnetic energy. Mineral deposits drift across fault valleys, and the residual effects of tectonic movements ripple outward. These are not audible or visible phenomena. They manifest in hesitations of compass needles, fluctuations in magnetometers, and even in the behavior of marine life that senses electromagnetic fields. The Atlantic communicates in a language written not with sound or sight, but with energy, force, and time. A language that requires patience, precision, and sensitivity to interpret. Hydrothermal vent fields amplify and modulate these echoes. Minerals discharged from vents, particularly iron and manganese, settle in patterns that can persist for centuries, subtly altering the magnetic environment. When deep currents carry these deposits across fault valleys, they create transient distortions, like whispers of past geological events. Each plume, each sediment layer, becomes part of a living archive, recording the interplay of energy, matter, and motion. The ocean is both scribe and storyteller, encoding the history of the Earth in invisible yet detectable signatures that ripple far from their origin. Seismic events, no matter how minor, also leave enduring marks. Microquakes, tectonic adjustments, and subtle shifts in fault lines realign magnetized minerals, producing cascading anomalies that propagate through the ocean's magnetic lattice. Over decades and centuries, these effects accumulate, creating a network of interconnected anomalies that record not just the present moment, but the layered history of movement, eruption, and drift. In these echoes, scientists can trace the passage of energy, the slow evolution of tectonic features, and the persistent dialogue between Earth's interior and the ocean above. Even at the surface, these hidden influences are perceptible. Navigators crossing high anomaly zones often report subtle disorientation, sudden compass deviations, or unexplained electronic fluctuations. These experiences are evidence of the Atlantic's hidden architecture, reaching upward from the depths to touch the world above. The ocean, calm and expansive, is shaped by forces that remain invisible yet profoundly influential. The echoes serve as reminders that the surface is only a thin veneer above a complex, dynamic system operating on scales of energy, time, and space that far exceed human perception. Some echoes form complex networks, connecting anomalies across hundreds of kilometers. A disturbance in one fault zone can influence distant areas, producing subtle but measurable changes. These interactions suggest coherence in what might appear chaotic, a system of energy, mineral alignment, and tectonic activity that operates as a vast, interconnected web. Observers detect patterns in this web, spirals, waves, and pulses that hint at an underlying order, a cadence that is imperceptible to the casual observer, but undeniable to those attuned to the ocean's hidden rhythm.